Trends in physics. Today I will have a talk at the International Conference on Trends in Physics in Pakistan. I will present online, obviously, since I'm in Swedish in the spring. But trends is a very interesting word when we talk about physics and advanced materials, because trends are not really fashion type of trends, because trends are much longer perspective things. If we think, for example, about the silicon material, then that is the groundbreaking material for transistors, and it was also used for solar cells and many things. And the processors and semiconductor use is exploding using silicon and other semiconductors. But many years ago, silicon was a tiny little bit piece in research with not good quality, and it was not developed. So during 60s, 70s, 80s, there was development from small scale research, and then it was more booming, and then you had larger wafer size, longer crystals, so you could have more wafers, larger area, more devices. But that journey took more than 30 years. So that is a long trend, sort of. And then on top of that one, when you have the silicon wafer available, then you can have trends as a spin-off, the emerging technologies, new things which come and go because they don't make it to the market. Some come and make it to the market and then form a vertical based on the silicon wafer. So they become small trends which just boom out very fast, like spearheads for the future. And that is the positive thing about wafer scale availability. And in nitrides, you had research about small pieces of indium gallium nitride. And then you had blue light coming out from small pieces. And that was research. And then it was developed, so you had more efficient blue light coming out. You combine it with the phosphor, and then you had a white LED. And today we have white LEDs everywhere for energy saving, but also design and other perspectives. So that is also a long trend thing. But the white LEDs are now used for verticals, for communication, design, and other things, in addition to the energy saving, which is the main thing for using the white LEDs. So they become trends, verticals of the new things on top of something existing. But the original research was made like 80s, and then it took many years to control that, and then 30 years passed, a long trend, on top of which one you have the vertical trends, or whatever to call them. And now I see this also in silicon carbide. 30 years ago, it was a basic research about small pieces of crystals with micropipes and defects and a lot of interesting things in physics. And now, today, it is a booming market in electric cars and other verticals. Thanks to the availability of the wafer scale silicon carbide, you start to have these verticals coming out that you can think of where, in addition to use the silicon carbide, than the main application, for example, electric cars. That's a big driving momentum. And on top of it, you can have other verticals. So it's other type of technologies or even power devices. Power devices used in data centers, between solar and battery and other areas. So they become on top of this platform technology and platform market. So those also trends, and now we have also photonics, quantum photonics and other aspects in silicon carbide which become new things and trends. So calling it a trend is a little bit strange for a semiconductor person, but if we think of it in that perspective, then we have the long trends, things which do not change fast, and then you have the fast changing stuff. Some of them will be implemented because they succeed, someone wants to buy this new technology, or they do not succeed and go away very fast. So there will be rapid changes in the interest of the emerging technologies from the wafer scale materials platform, which is the long trend on top of it. And on top of this one, you have the short trends or initiate trends, which might last for a long time, but everything changes and depends. So this is the interesting thing about connecting this to the physics, because it started with the physics of the growth, application point of view, light emission or whatever. And now, still there are many things in the physics which is very useful for the commercial market. When you improve the physics, you save money, and then you can do additional things related to how to use the data and information in the physics, which can actually be new business models in advanced materials. And that can also be a new trend. So this is a nice discussion to have, because this brings out what we have as ideas and researchers and what we can propose to be the new things and maybe the new trends.